Hello friends, this video on laws of motion part 10 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from part 1 to 9 before going ahead with part 10. We will now study about equilibrium of a particle. So what do we mean when we say a particle is in equilibrium? The term equilibrium, it has something to do with equal, right? It is something, the word seems something similar to equal. Equilibrium basically means something which is stable in normal English. In general English, it would mean something which is kind of stable. So a particle is said to be in equilibrium when the net external force on it is zero. Whenever the total force acting on a particle is equal to zero, we will say that the particle is in equilibrium. Let us take an example. Let us suppose that we have a box this way. Now we push this box from this end with force F1, push this box from this side with force say F2. Now if F1 is equal to F2, I mean magnitude wise, if magnitude wise F1 is equal to F2, and since they are acting in opposite direction, therefore the net force on the box is equal to 0, right? Because F1 is equal to F2 magnitude wise, and since the direction is opposite, therefore F1 is equal to minus F2. Now what is F net? F net is equal to the total force, that means F1 plus F2, but plus F1 plus minus F2. Now since both are equal, therefore it will come out to be 0. Now let us take another example. Here we see again three forces are acting on the box. Say this is F1, this is F2, this is F3. So in this case also we have a force F1, F2 and F3 acting this way, such that magnitude of F1 is equal to F2 is equal to F3. Now the sum of the three forces, because they act exactly in opposite directions, that is they act exactly at equal angles to each other, so we find that the sum of the forces is equal to 0. So we say that this body is in equilibrium. So in general what we can say? We can say that if there are n forces acting on a particle like F1, F2, F3, F4 and so on till Fn, and if sum of all the forces is equal to 0, then we say that the particle is in equilibrium. Now that we have seen conservation of momentum as well as equilibrium of particle, we will again solve few problems to make our concepts clearer. So here comes the first problem. A 1500 kg gun mounted on wheels shoots a 10 kg projectile with a velocity of 800 meter per second parallel to the horizontal. Find the horizontal velocity of the gun. So in this case, what are the values that are already given in the problem? We have two objects here. One is the gun and the other one is the projectile. So mass of the gun is given as, let us suppose M1, that is given as 1500 kg. Mass of the projectile, that is M2, is given as 10 kg. Also, initially the entire system is at rest, that is gun plus projectile. Gun plus projectile is equal to the system. Gun and projectile together constitutes the system here. So let us suppose initially the velocity of the gun was equal to 0 and initially the velocity of the projectile was also equal to 0, because initially the entire system was at rest. Now later what happened? Later the velocity of 800 meter per second came for this projectile, which moved parallel to the horizontal. That is, later V2 was 800 meters per second. So we are supposed to find the horizontal velocity of the gun. That means we are supposed to calculate V1. Now we will apply law of conservation of momentum. Now conservation of momentum states that the initial total momentum of the system should be equal to the final momentum of the system. So what is the total initial momentum of the system? System means gun plus projectile. So total initial momentum of the system will be equal to the total momentum of the gun plus the total momentum of the projectile initially when it was at rest. That means P in initial would be m1 u1 plus m2 u2. And what would be the final momentum of the system? That will be m1 v1 plus m2 v2. Now since u1 and u2 is equal to 0, so left hand side will be 0 and this would be m1 v1 plus m2 v2. Now we have to calculate the value of v1. So v1 comes out to be minus m2 v2 divided by m1. Now we will put the values here. That is m2 is equal to 10, v2 is equal to 800, m1 is equal to 1500. The value comes out to be minus 5.33 meter per second. So that means the horizontal velocity of the gun would be 5.33 meter per second. Now what does the negative sign indicates? It indicates that the velocity of the gun would be in the opposite direction. That means if the projectile is moving forward, the negative sign, what does this negative sign indicates? If the projectile moves forward, then the gun moves backward. That means in the opposite direction. So I hope the problem is clear now. So whenever you are given a problem on conservation of momentum, it is very important that you understand the problem, you understand the event which is taking place, and then try to find the values of the velocities before the event and the velocities after the event. In this case, what was the event? The shooting of the gun was the event. So before the gun was shot, everything was at rest. Therefore, the velocity of the gun and the velocity of the projectile was 0. After the gun was shot, the velocity of the projectile was 800 meter per second, whereas the velocity of the gun was unknown. So then we have used the conservation of momentum law and we can calculate the value of velocity. Now let us have a look to the second problem. The second problem says a railway truck A of mass 3 into 10 to the power 4 kg traveling at 0.6 meter per second collides with another truck B of half its mass moving in the opposite direction with a velocity of 0.4 meter per second. If the trucks couple automatically on collision, find the common velocity with which they move. That means we have two trucks here, A and B. Now truck A is traveling, the mass of truck A is given. We will keep writing the values as well. Let us suppose mass of truck A is 3 into 10 to the power 4 kgs. Also velocity of truck A is given, that is 0.6 meter per second. Now this truck A and truck B will collide. So we have to find the values before collision and after collision. So before collision the mass of truck A is this much and the velocity is this much. So before collision the mass of truck B M2 is half of truck A. Half of truck A means this would be 3 into 10 to the power 4 divided by 2 kgs. That is equal to 1.5 into 10 to the power 4 kgs. Correct? And the velocity of truck B before collision is 0.4 meter per second, but it is in opposite direction. Opposite direction, that's why we'll put a negative sign, 0.4 meter per second. Right. Now, with these values, and the question asks, if they couple automatically on collision, find the common velocity with which they move. That means what happens exactly is, suppose this is truck A, this is truck B. Now truck A and truck B collides and they couple together. That means they become one system. That is A and B becomes one system and they start moving together. So the collision has happened here. So before collision they were separate. After collision they started moving together. So we have to find with what velocity they will start moving together. So before collision, this is the scenario. And what about after collision? After collision, what will happen? So this was before collision. Now after collision we will write here. So after collision, what will be the total mass of the system? After collision, the mass will be equal to m1 plus m2. Right? So the mass will become 3 into 10 to the power 4 plus 1.5 into 10 to the power 4. That is equal to 4.5 into 10 to the power 4 kgs. This will be the mass after collision. And what will be the velocity with which this system will move after collision? That is what we have to find. Now let us apply law of conservation of momentum. So conservation of momentum states that the total initial momentum of the system is equal to the total final momentum. So what is the total initial momentum? Initial momentum will be momentum of A plus momentum of B. So total initial momentum is momentum of A plus total momentum of B. This will be equal to the total final momentum of the system. Now total momentum of the A will be m1 u1 plus total momentum of B would be m2 u2. This is equal to the total final momentum. So final momentum would be m into v. So from here we get v is equal to m1 u1 plus m2 u2 divided by m. Now we will put the values in this equation. So we will get 3 into 10 to the power 4 into 0.6 plus 1.5 into 10 to the power 4 into 0.4, but 0.4 has minus sign, so this will be minus divided by m. So what is the value of m? M is 4.5 into 10 to the power 4. Since I don't have space, so I'll do the calculation this side. So now v will be equal to 1.8 into 10 to the power 4 minus 0.6 into 10 to the power 4 divided by 4.5 into 10 to the power 4. So this will be equal to 1.2 into 10 to the power 4 divided by 4.5 into 10 to the power 4. So this will cancel and we get this value as 0.27 meter per second. Therefore, the common value of velocity with which the entire system will move after collision is equal to 0.27 meter per second. So we did nothing special in this example as well. So whenever we have any problem based on conservation of momentum, we just need to apply the conservation law, that is the total initial momentum is equal to the total final momentum. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.